Okay, so welcome back, and we are in the middle of our discussion about the atomic basics. And last time we talked a little bit about the mass of protons, electrons, and neutrons, where they're located, and their assumed charge. Now let us move on to the next consider, and we want to consider the following atoms. We have a neutral 20482 Pb, a 2613 Al3 plus, and a 12353I minus, and we want to know how many protons, neutrons, and electrons are in each of these. Well, it looks to me like we need some notes, and we need to understand atomic representations. So we were talking about atoms last time, and I came over here and I said we had certain particles, and those particles were the proton, the neutron, and the electron, right? And then I said, hey, we can representation, right? I could represent atoms, and one way I could represent atoms is I can have like an x dash number, and we said that the x was the symbol for the element, and that the number was something we called the mass number, right? And we said that the mass number is equal to the number of protons plus the number of neutrons. Good. Well, there's another way that we can represent atoms, and that is, I'm going to say big X, and then I'm going to go with a Y, Z, and something like that. Okay, so what's my big X? My big X is my symbol for the element. Again, my element symbol. The Y, this time my Y is my mass number, right? My mass number is zoink. What's my mass number equal to? Number of protons plus the neutrons. And Z is something we call the atomic number. And we talked about that last time. Remember, the atomic number, where do I find it? I look on the periodic table, we'll find the symbol, and up here, we'll find the atomic number. And what's the atomic number equal to? It is the number of protons. Good. And then this area up here, what is that? This tells me my charge on the atom. Good. And now, if there is nothing written there, nothing. That means it is what? Neutral. And if it is neutral, that means the number of electrons equals the number of protons. But let's extend the page here. What if my number up here is a positive number? Well, positive means what? It means it is not neutral. And what things are positive? Protons. So if it's a positive number, that means there are more protons than electrons. If it's a positive 1, plus 1, or 1 plus, that means there are one more proton than electrons. Good. If it's a 2 plus, that means there are 2 more protons than electrons. Good. Now what if it's a negative? Negative means it has a negative charge. The negative things are electrons, so that means I have more electrons, yikes, more electrons than protons. And I think you understand the whole process here. So I think that's all we need to answer this question. Oops, wrong question. Here we go. So I have a neutral atom of 20482 lead. Now what did I say? I said that the X, Y, Z, Y is my mass number, Z is my atomic number, and X is my symbol. So if I have lead 20482, that means my 82 is my atomic number. And what is that? That is the number of protons. So that means I have 82 protons. What's 204? 204 is my mass number. And the mass number, if you recall, is equal to the number of protons plus the number of my neutrons. So that means I have 204 is equal to the number of my protons, 82, plus the number of my neutrons. Solving for n, I get what? 122. 2, I hope. 122, 4. Yeah, that looks like a winner. So I have 122 neutrons, 82 protons, and it is a neutral atom. No charge here. That means what? If it's neutral, that means I have the same number of protons as electrons. If I have 82 protons, that means I have 82 electrons. Okay, so moving on to the next one. I have aluminum. Let's write this 2613, aluminum 3 plus. The 13 means what? That's the number of protons. So I have 13 protons. The 26 is what? 26 is my mass number equal to the protons plus my neutrons. So what is N? 26 equals 13 plus N. N equals 13. And the plus 3, or the 3 plus here, is what? The charge in this atom. It's plus, so that means I have more protons than electrons. 3 meaning I have 3 more protons than electrons, right? Yoink, let's add that. So if I have, where are my protons here? I have 13 protons. I have 3 more protons than electrons. That means I must have what? 10 electrons. So I have 10 electrons, 13 protons, and 13 neutrons. And for the final, we're looking at 123, 53 I minus. What's the 53? That's my atomic number, so that means I have 53 protons. 123 is my mass number, so 123 equals 53 plus N. So N has to be equal to, what do you think, folks? How about 70? Is that right? 70, 120. Yeah, 70. Good. And I have a minus 1. The minus means what? I have more negatives than positive. That means I have 1 more electron than protons. Well, if I have 53 protons, how many electrons must I have? I must have 54 electrons. Cool. Great. Let's see what you guys can do on your own. Here you go. Consider 238.92U and 65.29 copper 2 plus. How many protons, neutrons, and electrons? I'll give you, what do you think? 30 seconds maybe? That would be cool. Okay, go. Okay, here we go. Let's do uranium-238. So I have 238.92 uranium. What's that 92? Well, that's my atomic number. So that means I have 92 protons. So 92 protons. 238 is my mass number, which is equal to my 92 protons plus the number of my neutrons. So neutrons are equal to, what do you think, folks? 92 minus 6, 9, 4, how about 146 neutrons? Good, so I have 92 protons, 146 neutrons. Do I have anything written here? No, that means it's neutral. If it's neutral, that means the number of protons equals the number of electrons. So, what's my answer? 92 protons, 92 neutrons, and 146 neutrons. 92 protons, 92 electrons, 146 neutrons. Good. Now let's go to the next one. Copper. So I have copper 2 plus, and let's pop up here. What is it? 6529. 6529. What's this? There's my atomic number. That means I have 29 protons. I have a 65 for my mass number, so 65 is equal to 29 plus N. N is equal to, how about 36? 36, 50, yeah, 50, 65, 36. I have 36 neutrons, 29 protons, plus 2. It's a plus. That means more what? Than what? more protons than electrons. How many more? 2 more protons than electrons. If I have 29 protons, that means I must have 27 electrons. And there are my answers. 29 protons, 36 neutrons, and 27 electrons. Cool. Let's see if we can do one more before we call it a day here. And here's the next one. I have a neutral atom of Ca48, so that we know that now is what? Calcium. And the 48 we know is what? My mass number. Good. If one of the neutrons is transformed into a proton, what element does it become? Well, this is interesting, right? Let's say I have one of the neutrons transformed into a proton. Well, how many protons? Let's go back and let's look at my calcium 48. When I look on my periodic table, my calcium has what? Looks like a 20. So that means it starts off with 20 protons, and if this is 48, it must have 28 neutrons. Now I say this is transformed. What's that? This is transformed, and one of my neutrons becomes a proton. So that means I have 21 protons, and now I have 27 neutrons. Does this change my element is the question. Does this change this to something new? Well, it really goes into the definition of what makes up an element. What makes up carbon? The answer is all carbon atoms have one thing in common, and that is all carbon atoms have 6 protons. If it has 6 protons, it is carbon. If it doesn't have 6 protons, it cannot be carbon. So an element is defined by the number of protons. Good. So I started off with 20 protons, so that was calcium. Now I have 21 protons. Is that still calcium? No, I look on my periodic table and I see that with 21 protons I have scandium, right? Sc. And so I have a new element. So a new element was formed when one of the neutrons became a proton. Got it? It is the number of protons right here. This is the important thing right here. The number of protons defines the element. If you change the number of protons, you're changing the element. Doesn't matter about changing the neutrons, just the protons. Good. So you have a neutral atom of polonium-210. It expels, that means spits out 2 protons and 2 neutrons. What do you get? Give you 15 seconds. Okay, so here we go. I have polonium. I look at my periodic table, and when I look up at periodic table and see polonium, I see what? Polonium has an 84 up here. That means it has 84 protons. So I have 84 protons, and we have polonium-210. So 210 minus 84 looks to me like I get what? How about 126? 126 neutrons, and then that's transformed, and what happens? I lose 2 protons and I lose 2 neutrons, so I end up with 82 and 124. Now, do I really care about the neutrons? No, not really, because the neutrons don't change my element. It's the protons that make the difference. This is the difference maker. Difference maker, right? Good. Now I have 82 protons. I look on my periodic table. I have an 82 up here. What do I see as 82? PB. What is PB? Lead. And so, should have all said that the element becomes lead. All right. I think that does it for now. See you next time. Ciao.